Hello, this is Dr. Gardner. We're covering a second tutorial on dimensional analysis to show you how to convert units when you have slightly more challenging problems than we had shown you in the first tutorial. So in the first tutorial we'd seen how to convert a single unit with respect to our conversion factors and how to use several different conversion factors in a multi-step conversion. What we want to look at with this tutorial is how to use multiple conversion factor steps and more complex types of problems, as well as how to work with numbers that have two units that we need to convert in multiple steps. So hopefully you'll find this useful when you run into more challenging problems. Let's start with this first example problem. Let's convert 2 miles to a unit of centimeters, first of all. Now, whenever I start a calculation like this, especially the more challenging the calculations become in the course, I would want to plan out the steps in my calculation. So here I might consider the possible conversion steps I might use to convert from miles to centimeters. So let's say this is our plan. We're going to start with miles. And in my first step for this conversion, I'm going to convert to feet, let's say. So I want some type of conversion factor that will allow me to convert from miles to feet. I know I will want to cancel out units of miles, so that should be in the denominator. I should have feet in the numerator. So that's kind of my plan. We'll look at some useful conversion factors that will help us achieve this coming up in just a second. So that'll get me to feet. Now the next step in my calculation, I want to be able to convert from feet to inches. And so I need to recognize that I want to cancel feet out, end up with inches. And so I'm going to relate this to 1 foot having 12 inches, as we'll see soon. Now once I'm at inches, we still want to go to centimeters, so I'll have to have a third step in my conversion relating my conversion from inches to centimeters. So these are kind of the units I'm looking for in my conversion factors that I'll be using. So let's consider some useful conversion factors that will help me achieve this plan. So the first conversion factor we might look at would be 1 mile having 5,280 feet in it. That would allow me to achieve my conversion for step 1. And then another conversion factor that will relate feet to inches that you should all know is 1 foot is 12 inches. So we can relate that for our conversion factor for step 2. And in step 3, we're going to relate 1 inch to 2.54 centimeters. That's a good one to memorize. We can use that frequently to help us get from the English system to the metric system. So I'm going to ask you to memorize 1 inch is 2.54 centimeters. So this will provide me the 3 conversion factors I need for the conversion steps 1, 2, and 3 that we planned out. Now at this point, once I have all 3 of those conversion factors, we're going to start setting up our dimensional analysis. So everything we write is going to be in fractions. We're going to make sure the units cancel just like they were algebraic variables. So my first fraction I will want to begin with will be the 2 miles that we're looking at. And I can write any number as a fraction if I just divide it by 1. That won't numerically change the value of that number if I divide or multiply by 1. So I can divide it by 1, so 2 miles over 1. Then I'm going to multiply by a fraction that will cancel my units of miles, just like an algebraic variable. So I want to go ahead and have miles in the denominator for my next fraction, and I'm going to have feet in the numerator in order to convert from miles to feet for step 1 in my conversion. So I know there's 5,280 feet per 1 mile, so that's how I'll make sure I set up my fraction to cancel the units. And then for my next step, I would like to convert from feet to inches. So I want to make sure I have feet in the denominator for the next fraction, the bottom of the next fraction. So I'm going to recognize that I have 12 inches for every 1 foot. I can see my feet will cancel as units here. Once I'm to inches, then we're going to go ahead to step 3 for our conversion, and we'll want to convert from inches to centimeters. So my third fraction that I'm going to use here as a conversion factor to relate 2.54 centimeters for every 1 inch. So you notice we've color-coded how we're canceling units out. Miles are going to cancel first in blue, then feet in red, then inches in green. So at this point, I will want to see if all the units are canceling except for the units that I want my final answer in. So everything should cancel out except for centimeters. So here we see our miles canceling, our feet canceling, our inches canceling, and we're going to have 2.54 centimeters at the end that we're going to be multiplying everything by. So let's see, what do I do with these numbers in my calculator? I'm going to take all of the numbers in the top of my fractions and multiply those, all of the numbers in the bottom of my fractions, and divide by those numbers. So first of all, let's multiply all the numbers in the numerator. So I'm going to take my 2 miles times my 5,280 feet times my 12 inches times my 2.54 centimeters. Then I'm dividing by the denominator, the bottom of all my fractions. So I'm just dividing by 1, 1, 1, and 1. And you probably would recognize you don't actually have to do that in your calculator unless you have a number that is not 1 in a denominator, as we'll see soon. So if I went ahead and did that in my calculator, I'd find that my answer would be 3.22 times 10 to the 5th, and it would have units of centimeters, because that was the only unit that didn't cancel out here. So we would have 3.22 times 10 to the 5th centimeters for my units and my answer for this problem. Okay. Now you'll notice there's multiple steps in this calculation. Hopefully you're becoming comfortable with multiple step conversions. If you want to, though, we could have stopped at any one of these conversion steps and written down the answer in feet or inches, or gone all the way to centimeters. So feel free to break these into individual steps and writing down your answers after each step if you prefer that method as you're beginning. Should we practice again? Yeah, let's try converting some time units here. Let's consider if I was setting up the conversion factors for dimensional analysis involving converting 1 year to seconds. Now we're going to assume this is a non-leap year, so there's 365 days in that year to prevent any more complexity in the problem. So if we look at this, let's plan out our conversion. We're going to have multiple step conversions here because I'm assuming most of you, right off the top of your head, do not have memorized the conversion factor directly from years to seconds. So let's say here's the plan for our conversion. Let's say you know how many days in a year. So step 1 of my conversion might be converting from 1 year to days. Step 2 might be relating my days to hours. And so I'd have a conversion factor from days to hours that we're going to be using. So I'm going to have to find those conversion factors. I'm just showing the units here underneath in the fractions that we're looking for. And then for step 3, we're going to convert from hours to minutes. So I'll need to have a conversion factor that relates hours to minutes. I bet we all have that memorized. And then step 4, I could convert from minutes to seconds. So this is going to be a 4-step conversion with conversion factors with our fractions. And so I need some useful conversion factors that's going to help me achieve each of these conversion steps that I planned out. So I may recognize that 1 year, if it's not a leap year, is going to be 365 days. So I set that up for my conversion factor for step 1. Then I know 1 day is 24 hours, so that would be my conversion factor I'm using for step 2 here. And then I can recognize that 1 hour is 60 minutes, so that would be my conversion factor for step 3. And then I know that there's going to be 60 seconds and 1 minute, so that's my conversion factor for step 6. So I've actually written the conversion factors out. I predicted that the denominator will have the units that I want to cancel in each step, and the numerator at the top of the fraction will have the units that I'm achieving the conversion for each step. So let's go ahead and set this up for each of our steps in the calculation. So I first of all start with the 1 year. So I'm going to write 1 year as a fraction, so 1 year over 1 times my first conversion factor, and I'm going to recognize I want years in the denominator, cancel the units of years out, so I'll have 365 days for every 1 year. And then I want to convert from days to hours, so I'm going to recognize that I have 24 hours for every 1 day. Notice I put the days in the denominator, so my days will cancel out. I have everything color coded so you can see the units that will cancel here. Then once I convert from days to hours, my next step would be converting from hours to minutes. So I want my hours in the denominator here, so I will have 60 minutes as 1 hour, so I can see my hours as units will cancel. And then as I convert from minutes to seconds, I'll use my last conversion factor. I want minutes in the denominator, so I'll notice that I have 60 seconds for every 1 minute. So we can see the blue years should cancel units, the red days should cancel units, the green hours should cancel units, and the purple minutes should cancel units. To provide the only units that do not cancel would be seconds. So my final answer should be reported in seconds. Let's go ahead and confirm this. So let's check that all of our units are canceling as set for seconds. So we're treating these, as you recall, all like algebraic variables that we're canceling out the variables. So if you're having trouble with visualizing this, put in X's for the blue years, Y's for the red days, Z's for the green hours, kind of see how they're all would cancel out just with the variables you might be used to and comfortable with working with in an algebra course. So here we can see our years cancel, our days cancel, our hours cancel, our minutes cancel, and we would have seconds for our final units. Now what I would do to actually perform this calculation in my calculator, I'm going to multiply by everything in the top of the fraction, so all the numerators are going to be multiplied, so I'm going to take the 1 year times 365 days times 24 hours times 60 minutes and times 60 seconds. Okay, and then I'm going to divide by everything in the bottom of my fractions here. So that's just going to be the 1 year, 1 day, 1 hour, 1 minute. I'm going to divide that into my numbers. So the ones won't change anything, but we will soon see a calculation where they are not all ones in the denominator. So make sure you're still looking at them. And so my final answer would be 3.15 times 10 to the 7th, and we know the only units that did not cancel were seconds, so the correct answer to report would be 3.15 times 10 to the 7th seconds. I always want you to report your numbers with units, and especially your final answer with units, and put a box around your final answer so I know that is the one you would like me to grade. So now we know 1 year has 3.15 times 10 to the 7th seconds in scientific notation. You might want to practice converting from scientific notation back to a standard decimal form number to see how large this number would be for extra practice before your next exam. Now let's consider when we want to convert numbers that have multiple units. So let's say that somebody is traveling down the freeway at 80 miles per hour, but we would like to convert those units from miles per hour to meters per second. So now we have two sets of units to convert. We're going to see how we can go ahead and set these up to convert all the units simultaneously using dimensional analysis, making sure our units cancel to keep track of everything. So first thing we should do, plan out the calculation. What steps do we predict we might use conversion factors for this calculation? So the very first part of this calculation, let's look at the miles. Let's convert our miles all the way to meters. So what steps might we use? Well, let's say we plan on converting my miles to kilometers. If I do so, I can find a conversion factor for miles to kilometers, or I might have one memorized. Then for step 2, I'll convert from kilometers to meters. So this would allow me in a 2-step conversion for the miles to convert to meters. And then my second conversion, I want to convert from the hours to seconds. So let's say I'm going to do that in 2 steps. You might be able to do it in 1 if you know the conversion factor, but let's go ahead and go from hours to minutes, because I know there's be 60 minutes in an hour. And then for my last step, step 4 here, I'm going to convert from minutes to seconds. So we're seeing we're both converting the miles and the hours. Now, the conversion factors we're using here is I need to recognize that there's 0.62 miles for every 1 kilometer. So there's my conversion factor for step 1. I'm not going to write it under step 1 for this example because you've seen that several times, but feel free to do that if you want to print out these PowerPoint slides and keep track of it. Then I'm going to convert from kilometers to meters, and I recognize with my metric system that 1 kilometer, 1 kilometer, is equal to 1,000 meters, or 1 times 10 to the 3rd of the base unit, meters. I recognize 1 hour is 60 minutes for my step 3 of the conversion for the time units. And then I recognize that 1 minute is equal to 60 seconds. Again, a conversion for my time units here. So I have all the conversion factors I need for step 1, 2, 3, and 4 in the conversion. Now what's new here though is when we write our first fraction, there's going to be 2 units in the initial fraction. So I'm going to write 80 miles, but it's 80 miles per 1 hour. So the top of my fraction is 80 miles. The numerator is 80. I'm dividing by 1 hour. That's the denominator, the bottom of my fraction. So I have units in both places to keep track of. It works the exact same way as in our previous examples for keeping track of units, though I just want to make sure I cancel them like algebraic variables. So let's start with the first part of our plan. Let's leave the hours alone to begin with and convert the miles. And you're welcome to break this into individual steps and write down the answer at each step if you want to pause. If that makes you more comfortable, you should still end up with the same final answer that we have. So my first conversion, step 1, I'm going to convert from miles to kilometers. So I know I want to cancel miles, so I should have my miles in the denominator in the bottom of my next fraction. So I take 0.62 miles. I'm getting this from my conversion factor. Now that's for every 1 kilometer. Okay, so I can see my miles will cancel there in blue. Now I want to convert from my kilometers to meters for my second step. But feel free to write down the answer for this first step if you'd like to. You would have an answer in kilometers per hour if you stop here before continuing on. Now next I want to convert from my kilometers to my meters. So I need to have kilometers in the bottom of the next fraction I'm multiplying by for my conversion factor. So I'm dividing by 1 kilometer, and I'm multiplying by 1 times 10 to the third meters. So I'm getting that from the second conversion factor we had here. Easy to remember which way to write the fraction because the kilometers should cancel units, correct? Now once I have my meters, I should be able to convert that's the final unit I want for my distance. I should be able to convert time next. So I'm going to leave the meters as they are. I can see my miles will cancel, my kilometers will cancel. And then I want to convert my time. Now notice the 1 hour is in the bottom of our initial fraction, in the denominator. So I want hours in the top of the conversion factor fraction that I use. So be careful. That's the reverse of what we've been seeing before, because before we had our units in the numerator rather than the denominator. So be very careful you don't accidentally invert this fraction in your calculation. So I'm looking at my conversion factors. I have 1 hour is equal to 60 minutes. I should have the 1 hour on the top and 60 minutes in the denominator. So I can see the yellow 1 hour, the hours as units will cancel. Okay, so that'll get me to minutes. So now I have meters per minute for my units if I were to write down my answer at this step. Now I want to convert from minutes to seconds though, so my next conversion factor will need to cancel my minutes out and then have seconds in the denominator. And that's what I want. I want meters in the numerator and seconds in the denominator for my final answer, meters per second. So I have 60 seconds in the denominator and 1 minute in the numerator. Okay, and then I should check to make sure all my units are canceling the way they should to give me final units of meters per second. So let's see if they cancel out. My miles cancel out. My kilometers cancel out. My hours cancel out. Okay, you notice our hours are canceling out even though I started with hours in the denominator here. I make sure that I did not accidentally invert this fraction. Now then my minutes should cancel out. So I'll see my minutes cancel out. So I have units here of meters per second for my final answer. Okay, so what I'm doing in my calculator to find the answer, I'm going to multiply all the numbers in the tops of my fractions, all the numerators, and then I'm going to divide by all the numbers in the bottom of my fractions, the denominators. So I'm going to go ahead and take the 80 miles, multiply it by the 1 kilometer, multiply it by the 1 times 10 to the third meters, multiply it by the 1 hour, multiply it by the 1 minute. And I'm dividing by all the numbers in the denominator, so I'm dividing by my 1 hour, I'm dividing by my 0.62 miles, I'm dividing by my 1 kilometer, I'm dividing by my 60 minutes, and I'm dividing by my 60 seconds. So the final answer I should have would be a number of 36. Now this has units, if you recall, of meters per second because those were the only units that we didn't cancel out, and they were our goal for the whole conversion. So I write my final answer as 36, and I make sure I show my units to get full credit, so I show 36 meters per second, and I put a box around my final answer for my instructor so that they can easily find it, no matter how much planning and conversion factors and work I might have recorded on my paper. So let's try one more double unit conversion, so when we have 2 units. Let's consider the following problem. So let's say that we are told that 0.7 micrograms per milliliter of blood in a child can lead to severe damage of their body and even potentially to death due to the lead poisoning. Now, this is in micrograms per milliliter. Now remember, micrograms has units. We're using the Greek letter mu for micro in front of their base unit of g. I don't put an m there because that would be milligrams, so I indicate the micrograms with this abbreviation. Now we want to convert those micrograms to grams, and we want to convert our milliliters to liters to get our new set of units. So I'm planning that out. Very first conversion, micrograms to grams. So I take my 0.7 micrograms, I'm going to convert that to grams in the first step. And then for my second part of the conversion, I'm going to take the milliliters and convert them to liters. Okay, in step 2, so I need to come up with the conversion factors to help me convert from micrograms to grams. You should all have in your head the metric system prefix conversion so you can convert from micrograms to grams. And you should also have your milli to base units, so your milliliter to liter from your metric conversions. So it's very important you make sure you have those conversion factors memorized for your prefixes. So here's the conversion factors I'm using. 1 microgram I know is 1 times 10 to the negative 6 grams. Okay, it's going to be a millionth of a gram. I know that there's 1,000 milliliters for every 1 liter. I could have written this also as 1 milliliter is equal to 1 times 10 to the negative third liters, and that would have been the same relationship here. I'd be saying there that 1 milliliter was 1,000th of a liter. Either one could be used for the conversion factor. The ratio is still the same. So if you put the other conversion factor, you'd get the exact same answer unless you inverted something. So as I set up my calculation with the dimensional analysis, I'm going to write my initial fraction from the information given. So I have 0.7 micrograms for every 1 milliliter. We were told there was 0.7 micrograms of lead for every 1 milliliter to reach this toxic level that we're discussing. Now I'm going to start with my conversion of the micrograms. So my first conversion factor relates 1 microgram. I make sure it's in the denominator so my units will cancel. So I'm making sure I have micrograms here in the initial fraction. I'm dividing by micrograms, and the next fraction for my conversion factor should be in the denominator. So I'm getting this conversion factor here from 1 microgram as 1 times 10 to the negative 6 grams. So I should be multiplying by 1 times 10 to the negative 6 grams per 1 microgram. So that's my first conversion factor. If I wanted to, I could write my answer down now in grams per milliliter. Or we can continue on and convert now from the milliliters, and recall they're in the denominator now in our fraction, so I need to have them in the numerator, the top of the next conversion factor. So I could write that every 1 liter has 1,000 milliliters, and I can see now my micrograms will cancel, my milliliters will cancel, I'll get units of grams per liter. And I've just converted 2 units for this calculation. Fairly simple here, only a 2-step conversion as long as I'm keeping track of what's going on with my units. The place I see most students start to get in trouble is when they get into the bad habit of maybe not writing all their units down. So please write all your units down. If you also are having problems with calculations and you've written out the calculation showing all of your units, I can help you very quickly find your error, or many times you'll find the error before you even come talk to me, which is very useful if you're working at home on a problem. So let's make sure our units are canceling out to give us units of grams per liter for the final answer for this problem. My micrograms will cancel, my milliliters will cancel. I have units of now grams per liter for the final answer, so I have an answer here of 7 times 10 to the negative 4th grams per liter if I report it to that concentration unit. Now this is my final example for this tutorial. Please let me know if there's other specific examples you would like me to create tutorials for in the future, but I hope you'll find this quite useful.